Okay, guys, we'll just wait for 5 minutes, let others join, then we'll start off. Okay. My voice is audible to you?
Yes, ma'am.
Yes, ma'am.
Okay, okay, fine. Then we'll just wait 5 more minutes. Okay.
Good evening, ma'am.
Good evening. Okay, guys, let's just start today's session. So let me just present my screen. My voice is audible to you, right? Uh, you are able to hear me properly?
Yes,
Is
ma'am.
there any issue with my
Yes,
voice?
ma'am.
No,
Yes,
ma'am.
ma'am.
We can hear you
Oh,
very easily.
okay, great. So I'm just sharing my screen. You people let me know, is my screen visible to you or not?
Yes, ma'am.
Okay, ma'am.
Okay, just visible. My screen is visible.
Not yet, ma'am.
Not
Yes,
visible.
it is visible,
It's
Yes,
ma'am.
ma'am.
visible,
Yes,
ma'am.
ma'am. It's visible now.
Okay, okay, fine. Great. So yesterday we have done till this hyperparameter tuning and final model selection and testing. So we are left with this deployment part. We'll see this deployment part today, and then we will see some of the machine learning algorithm stuff. Okay. Well, just like yesterday, how we have taken examples and understood the stuff. Today also we'll try to do the same, right? So, what you people think about deployment? Anyone have any idea like how we can do the deployment and why it is needed for the deployment? Why it is needed to deploy any of your machine learning model?
To deliver it to the clients, we'll have to deploy.
Yeah, that is needed. Anything else?
According to the customer requirements, the model can be tuned and deployed to their businesses, ma'am.
Okay, yes, right. So basically, deployment, like after we are done with this training, validation, test phase, all of this things are being done, then the final step we need to consider up is deployment stage. That is the final stage in this to showcase any of our real life or real world use. We need to deploy it so that the user, any of the project base we are working on, so that the user get access to use it and also get the access to use that smoothly without any hassle. We need to use it, like deploy it basically. Okay, so what is the purpose of deployment? So in that case, if you are thinking of the purpose, we can think of to make our predictions, whatever be our predictions that we have done with our model, that need to be accessible to the user and also to the other applications or maybe any of automated system also, right? So that is the purpose we need to deploy that. So in that purpose, we can think of that. Spam detection model. So that need to be deployed where in Gmail, right? So that automatically the filters, the filters can spam, like we can get the filters out based on if the mail is spam or not spam, right? Guys, understood?
Yes, ma'am.
Yes,
Okay,
ma'am.
fine. So, where specifically we can deploy our projects and where deployment basically happens? We do have a question like that in mind, right? So basically, we can do our deployment in web application, in case of mobile app, in case of embedded system, if there is any embedded system, like models are deployed in case of IoT devices, sensors. In that case, we can we can deploy our project. In case of web application, you can think of a website also. There you can deploy your project. Mobile apps are very useful. You can integrate into any of the app with any of the real-time prediction. You can think of like when your footsteps are being monitored or your heart rate is being monitored. That thing is also a model that has been deployed in any of the app specifically, or you have deployed it in the form of app, and we are getting it in a mobile and downloading it in the form of app and using it in mobile. So you can think of as APIs also. So APIs also we can do it. We can try and use that in that format. So there are many deployment options as well. After where we need to deploy, where we can deploy our model, the very next question that we get is the deployment options basically. What are the deployment options we are basically getting? So we can do it online. We can do it any real-time deployment like online deployment option, online also we can do it. We can do it the batch deployment like the model processes as large sets of data are once produced, then we are deploying it. So that is batch deployment, right? So this is actually what are needed in case of like it is actually the deployment options basically that we actually get. So there are certain steps also in case of deployment. So first is model exporting. Like suppose, like let me just write it for you. Deployment. So under it, we will be writing like the first is model exporting. So what we are doing in case of model exporting, suppose you have done with model training, testing, everything is done. After hyperparameter tuning, you have tested the model. It is working fine. It is working good on your data set or any of the test data set. It is working very well. So you are satisfied with the model. So you need to save your model, save your trained model, right? So without saving that, you won't be able to use it, like deploy it. So for saving that, so you need like you need to save your trained model. So you can do it in PKL for Python or .h5. You can think of .h5 model for Keras, right? So that is the way you can go ahead and deploy the model for the very first step. That is the model exporting. So in that form, like in .pkl or .h5, in that format, you can export your model, your best run model, you can export out, right? So after that, after model exporting, what you can do, you can create the interface, create interface. Okay. Creating interface is another way, like when we are using web or mobile interface to give the inputs. When let me just show you an example. Yes. So this is one of my projects. So there I have used it with Streamlit. I have created the app using the Streamlit. So here I have used the website basically. So here we are giving the option, like this is the interface where the user will put any of the product and based on that get the similar product presentation the person will be getting. So this is how we can think of about creating an interface that has been needed up. Okay. Next, after creating an interface, you need to integrate with application. That is, you need to connect your model with the interface or the system, okay, with which you are basically creating. So the third step is integrating with application. Okay. So after that, after you have integrated, you need to do the monitoring and maintenance. Monitoring and maintenance is needed. Like you need to keep a track on your model performance, how your model is performing, what is the accuracy level it is giving, and how it is handling the error. All these things you need to take into account. So for that, after integrating with application, you need to monitor and maintain your model, maintain your the model that you are having on. So for that, you need to keep a track. You need to keep a track on the model's performance, accuracy, how the model is handling errors. This all things you need to check on. So the fourth step, what it is monitoring and maintenance. Monitoring and maintenance is the fourth step that you can think of. Next, suppose it is working fine, but there would be similar way that you have to update your model based on its performance. If the model's performance suddenly drops, you need to retain and deploy when the model's performance gets dropped or new data, new kind of data is available. Then you need to try and update. Like since you have seen like our phone, there are some points we are getting updates on our phone, like new features are coming into the phone. So similarly, your models, new features can also be included in your model, or there might be any available new data set on which you want to train your model, or you want your model to be available in that form. So in that sense, you need to keep on updating your model. So the fifth and the final step is updating the model. Here, guys, understood this much? What are the steps
Yes,
and
ma'am.
how it is being
Yes,
used?
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, okay, great. So after this, we can think of about the tools and technologies for deployment. So we can definitely use Flask, Django, then Fast API. This actually creates APIs in Python. All this, what I told, like for Flask, Django, and Fast API, this actually creates API in Python. So this is one of the form where you can deploy it using API form. Next is Streamlit, you can think it of. As I shown you the example, there I have used Streamlit to build an interactive dashboard for the model or any website based where we can deploy the project. Okay. So you can use Streamlit or you can use any of the cloud platforms like AWS, Azure, GCP, any of the form to like scale, like which is scalable. You can use that form to go ahead and deploy your project. And also you can do it in Docker, Kubernetes, okay? That in there also you can just deploy your project. Fine? Clear? Understood, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. Okay, great. So we'll just move in and see what are the machine learning algorithms that you can see up here. So here basically we can see in linear model we are getting linear regression, logistic regression, we are getting ridge regression, lasso and elastic net also we are getting. So we are getting a tree-based algorithm that is decision tree, random forest, extra trees we can think, extremely randomized trees basically when we are getting extremely randomized trees, there we are using this extra trees. Then we are getting this gradient boosting machine. This one, a gradient boosting machine, XG boost, that is extreme gradient boosting we are doing, then light GBM and CAD boosting. Basically, in any of the model, varied model you are working, varied data you are working on, you can definitely see and understand like there are certain forms where you can like this XG boost, like if you are using any of the simple model in the previous section, suppose you are using linear regression, you are using decision tree, then you are using XGBoost. There you will get for XGBoost the data or the accuracy level is very high. In most of the cases we get to see this, but there are exception also because that is based on the data, right? What data we are using, what data set we are using, and how we have like pre-process the data and what like feature engineering we have done. After that only we are doing all of this process, like we are selecting the model, which model to be used, right? So this thing like gradient boosting machine, XG boost and light GBM, this works really good on most of the data sets. Next, after this, we can think of like a support vector machine. Like there is a support vector machine, like support vector for classification and support vector for regression. Okay. Next is nearest neighbor algorithm, that is K nearest algorithm, KNN classification. We are very well to know about this algorithm. Next is the Bayesian algorithm, that is naive Bayes, that is Gaussian, multinomial, Bernoulli. All of this comes into this naive Bayes forms actually. Next, we can think of this Bayesian network and discriminant analysis, like the linear discriminant analysis and quadratic discriminant analysis. PCA basically we are doing in case of scaling and before in the form of scaling, and after that when we need to reduce the dimensionality, there we are using PCA. Then we are choosing any of the models. Okay, and neural networks are also there. So neural networks and this ensemble learning, so this we will be learning in later sections of our internship basically. But that also gives a very good result in neural network. We get to see about perceptron, that is the single layer neural network, multi-layer perceptron, convoluted neural network, recurrent neural network. So when we are handling very vivid or any kind of data that needs a very intricate use or very intricacy needed to be there, very logistical part is there needed to be there. There we are basically using neural network, and ensemble learning we are using where we are generally doing bagging, boosting, stacking, generally combining more one or more algorithms together to make that model work even more better. Okay, so these are actually the supervised machine learning algorithms. So we'll see this linear models today. We'll try start with this linear regression, and accordingly we'll move forward. See the major some of this major algorithms where we can work and we can train our model. Okay, clear, guys?
Yes, ma'am.
Yes, ma'am.
Okay, okay. Just
Yes,
allow
ma'am.
me a moment. Just okay. So we'll start off with linear regression. So anyone wants to put in their views or their knowledge related to linear regression? Anyone?
Ma'am, basically, linear regression is a way to find relationship between dependent variable and the independent variable, in which dependent variable is basically the target, and the independent variable is the data on which we have to find the target.
Okay, okay. Anyone? Anything else? Anyone?
Can I,
Anything else?
can I, can I,
Yeah, yeah, definitely can.
yeah, linear regression is the fundamental of statistics and machine learning, ma'am, techniques, which
Linear
is used
regression
to,
is?
is a fundamental of
I
statistics,
just
ma'am, and machine learning technique,
okay, okay.
used to model the relationship between dependent and independent variables.
Okay, got it. Fine. Okay. So as they say, it is we are just considering it up like that. So linear regression is we can think it of as one of the simplest and most widely used supervised machine learning in any of the form where we are working with continuous numerical values or numerical data we are being given with. There we are using linear regression. So linear regression, in what is the purpose? You can think it of. So it predicts the continuous numerical value. Like yesterday we have discussed about the house price. We can think about age, salary, based on one or more input variable, like the features X. Like let me just write it for you. Here X is the features or the independent variable. Okay, and next is Y. Y is the label. Actually, here we are basically discussing. This is a supervised learning. We do get the labels up. So why we are considering as labels only. So y as label, and next is it is the dependent variable. Okay, it is the dependent variable. So x is basically we put it as input. And there are some, in case of testing also, in case of testing, we are putting X as input and get Y as output. But in case of training phase, it is different because we are giving both X like input and output, the feature and the label we are giving to the model so that it learn from that. Okay. So this is how, this is what the inputs are basically. So when we are getting continuous numerical value and based on that one or more input values, we need to predict something, then only we are using linear regression. So based on that, we can think of the example that we have gone ahead with. We can think of like predicting the house price based on the size of the house. We can also think of the salary based on a person's experience. Suppose a person is having 4 to 5 years of experience,
इससे
what
वो
would be the
क्या कहते हैं
salary of
गूगल
the
फोटोज में
person?
खुल रही है क्योंकि वो भर ही ज्यादा
Yeah, who is
डिलीट
this?
करने के लिए भी कुछ करने के लिए नहीं।
Every time, why you people do this? Okay. What I was saying, like in case of predicting salary based on the years of experience that is there, so we are doing it like we can think it of like that, or we can also think it of like predicting sales based on the product reviews or or the marketing budget you can think of. So that all comes into the real life example of supervised learning where we are using this linear regression because there we are getting continuous values. We are getting this continuous values. So we'll see we are getting basically two types of linear regression. One is simple linear regression. Another is the multiple linear regression. So we'll see one by one how things are in case. So first is simple linear regression. So how it is? Sorry, just a moment. Yes. Yeah. In case of how we are doing with simple linear regression, so it involves only one variable, one independent variable is involved. So what it is? Only one independent variable and only one dependent variable. So in case of simple linear regression, what it happens, we are involved with only one independent variable, that is only one x value and one y value is there. So similarly, you can think of this example that we have discussed yesterday. So this is an exact example of a linear regression, simple linear regression, right? So how we have discussed this we'll just go ahead with that. So in this case, what are the inner intricacy that we have considered up and what type of, and how we are going ahead that we will be discussing here. So in case of simple linear regression, we only involve one independent variable and only one dependent variable is used. So basically, what it does, it helps us getting the prediction on the data. So why we are considering that example, yesterday's example itself. So Y is basically the house price, and X that is actually the target variable, and we are getting X That is actually the size of the house. Size of the house. Okay. That is the dependent one. Independent one, sorry. Independent one. Or you can call it as feature also. Okay. So what equation it does follow? So equation it does follow, that is equal to P0 plus B1 into X. Okay. So equation is Y. Y is the output. Okay. So Y equals to B0 plus B1, B0 plus B1 into X. So what actually it is? Y is the predicted value. What is Y? Y is the predicted value that we are getting as output. What the machine is or the model is predicting the output. That is Y. That is the predicted value. Next, X. X is the input value. Okay. Next, we are getting B0. B0 is the intercept and B1 is the slope. Okay. So B0 is when like intercept the value of Y when X equals to 0 and B1 that is the slope, that is how much Y changes for a unit change in X, that is slope. Okay. So let me just give destroy for you. So this is the y-axis that we are getting. This is the x-axis we are generally getting. And we do get a line like this. So everybody have learned this straight line formula, like, so this is actually the straight line formula where we are getting in through with x as the input value, y as the output, like the predicted value, b0 as the intercept, and b1 as the slope. Right. So you have think it of like this example itself. Yes, yesterday's example. So for this X data, 2,200, it has given the value of 2,70,000. So this is why this is actually the prediction that the model is giving. And this X is the output, like the input that has been provided up. So this form is actually been like this formula has been actually used up in case of linear regression. So what we are doing in case of multiple linear regression, just like the previous one, just like the simple linear regression, what we are seeing, we have seen only one independent variable and only one dependent variable. So it involves two or more independent variable. Against this, it will give a single dependent variable. Right. So it is like this. The similar way we can write the equation for this. Equation would be y equal to p0 plus p1 x1 plus b2 x2 plus so b3 x3. So similarly, it will go. Okay, till bn xn. Sorry, just a moment. Bn xn. So this is actually the form of multiple linear equation where x1, x2, x3 all are the different features. Like in linear regression, we have gone ahead only with one feature. In case of multiple linear regression, we can go ahead with multiple features, multiple independent variables can be there. Okay, clear guys, understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, got it.
Yes, ma'am.
Okay, fine. Okay. So basically, next we will be learning how linear regression actually works. The very first step or the agenda is to fit a line. Fit a line. Like in case of linear regression, we try to draw the best fit line through the data points. Whatever be the data points that we are getting, so we want to cover all those lines, all those data points, and based on that, like see, suppose let me just show you. Yes. So let me just show you. These are the data points we are getting. Okay, so similarly, these are the data points that we are getting. Okay. So just a minute. So it's not mandatory. It will fix all of the line. Okay. So suppose as we have given this in this table, in the above table, we have got values of x and values of y. So suppose similarly, we just have plotted this in this. Here we have just plotted it and we got this points up. Okay. So we need to check how, like, where we are getting the line. We need to get the best fitted line through the data points, right? So here you are seeing 1, 2, 3, 4, 5, 6, 7. 7 points are getting through this line and 3 are remaining. But except that if we want to draw it like this from here, from this point to this point, from this point to this point, we will be getting only 2 lines, that is 2 points that is covering. All these remaining points will not cover. So our main intention is to draw the best fit line through our data points. So this is the best fitted line where we are getting most of the data near or uh, with this line or with this point itself, and this others that are staying outside, that we can consider it as outlier for that very specific stage. Okay, then we need to do the minimization. We need to minimize the error, like the difference between the actual value and the predicted value. Yesterday, I told you about how we are getting the difference. That is the difference between the actual value that is there against what the model is predicting. That is the difference actually. So our next target is to minimize the error. So what we can do, we can use the formula, we can use the form of least squared error, that is SSE. Okay, there we are using this residual formation where we can use, like, the goal is to find the line where the SSE value would be minimum. So for that we need the value to be calculated. So how SSE is been calculated? That is squared error. That is the sum of squared error actually. SSE, sum of squared error. So here what we are actually doing, we are doing summation operation. So sum operation we are doing with y minus y predicted. Y predicted, that is, I am just putting it as y, this one, this is the symbol of y predicted, closing the bracket and doing the square of it. Doing the square of it. Okay, so this is the square error, sum of squared error. So in linear regression, we generally use the method called least squared, or to minimize the sum squared error basically. So this is how we are actually doing it in this form. Okay. So this is exactly, this diagram is clear to you what we are doing and how we are basically, what exactly is our viewpoint and how we are doing it, guys.
Yes, ma'am.
Guys,
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
everyone, sorry.
Yes,
Yes,
ma'am.
ma'am.
Okay,
Yes,
okay.
ma'am.
Everyone clear, right? Everything is clear,
Yeah,
right?
ma'am.
Yes.
Yeah, right, ma'am.
Okay, fine.
Correct.
Okay, fine. Then we'll just move in, just a minute. Then we'll just move in with the code. We'll see a normal, simple code in case of linear regression. Okay. So here is the code. Okay. So here basically what we did, we have just gone ahead and imported the libraries. We have imported pandas because we would be needing it further to create the data frame. Next, we have used from model selection, we have used imported train and tests because training and testing would be very much required in this section because we need to split the data into training section and testing section specifically. And then we need to go ahead with, then we have gone ahead with importing linear regression from sklearn linear model. So that we actually did because here we are not creating like going ahead and run like writing the whole code from scratch. We already have the library, so we will be using that and we'll be fitting the model in there that in that model itself. Okay. Then for the matrix, basically for evaluation purpose, we have used mean squared error and R squared error, basically. So here after we have gone ahead and imported all of this. Next, we have created the sample example data set. So where we have taken years of experience, what is the years of experience of a person? Based on the years of experience, what is the salary range? Okay, so this is the data, like this is actually the data set basically that we have created, example basically. So we have inputted in a variable named data. So now we have just creating the data frame. For that, we have used that PD and data frame creation. That is how we have created the data frame. Now, after creating the data set, like data frame we have created, now we need to just split the data. So for splitting the data, we just splitted the data into two forms, X and Y. So X, DF, years of experience, that is, X is a 2D column. Like what is the shape? It would be like what is 1, 2, 3, 4, 5. So 5 cross 1 would be like 5 rows, one column. That would be the shape of X, and it is needed to get into a series format. Okay, so we will be getting it in a series format and we will be putting it against X because that is our like independent variable, and salary, this is our target variable. So X, we have created the data frame like that, and Y, we have created the data frame as salary. Now after that we have divided into X train X test and Y train Y test. We have created it so that we can just divide it into a form so that we can keep the test size as 20%. See, test size we have kept 0.2. That's why what we are doing after training, we are keeping like based on the splitted data, we are keeping like 20% of the data we are keeping for the test purpose, and rest we are putting it for the training purpose. Okay, so then we are doing the train model part. We are training the model actually. So in this case we want to fit it in, like after this moment we just train the model using linear regression. So we train the fitted model using linear regression and have putted the values up here, like where in which variable we have kept the train data. So X train and Y train, that is both the feature and the label has been given to the model for learning purpose. So it is here we are going and the model is being learned and now we are predicting. Now in the X, this is the testing phase, predicting phase or the testing phase you can see where Y predict. This is the value where the output will be predicted based on the model. Model is the linear regression. So model we have created predict across what? That is the X data, X test data. Any of the data will be taken from the test section and we will be predicting the output. Okay. So now after it's been done, we will be checking the performance. We will check the slope. What is the slope of the like the line that we are getting, the intercept, the R2 score, like the R squared score basically, and MSE score, that is mean squared error we will be getting. So this is how we have printed. So we have got the slope is like that. Our score that is none because of the data, because we have taken it like that. We have created it none and MSC is also 0. So if we are working with any of the valid data set like a CSV file, then we can create a like get a more exact view on that. Okay, understood?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
okay,
Okay, ma'am. Okay.
okay, got it. Okay, okay, got it, fine. So next, we'll move into linear regression, like simple way we have already learned how we can implement it and what is the base that we have already been created. So for that very model, we will be taking into consideration how to fit a line and how we are getting this prediction up. So we'll just take some data and we'll perform all the steps and we'll see how we can take into count with that. Okay. So now,
Ma'am, I have doubt, ma'am.
yeah,
We are given testing size 0.2, right, ma'am?
yeah.
Yeah, for according to the projects, we can change the testing size, ma'am. According to the data.
Yeah, basically what we do actually, we generally keep the 70%, 70 to 80% of the data for training purpose and 20 to 30% of the data for the testing purpose. That is the standardization. So that's why I have kept the 20% of the data for testing. Okay.
Yeah, okay. Okay,
So
ma'am.
that because we can't keep the entire data like 70% of the data for testing, then how the model will learn, right? So for learning, we need to give more data to the model so that it can learn, understand the intricate details or the hidden pattern that is there inside the data. So we need to give the major part of the data for the training purpose, and we generally keep this 20 to 30% of the data for the testing part. Okay, clear?
Ma'am,
And if we want to increase that testing, if the model want to well perform means we can increase the testing that, ma'am, 0.5 like that.
0 point,
That
yes,
means
based on the thing we can create, but that is standardized that I am saying. Like we need to give major part for the training purpose. Major part of the data need to be given to the training purpose so that the model can learn. Without learning, we won't be able to get in through, right? So we generally keeps 20 to 30%. That there I have gotten to and got around 20% of the data. You can maximum change it to 30%, right? Because major data needs to be given to the model for training purpose. Until and unless, like our main intention is to make our model learn, train well, right? If we don't give the exact amount of data, how the model will get trained, right?
yes, ma'am. Okay, ma'am.
Yeah. Understood?
Yes, ma'am.
Okay. Anyone having any question?
ma'am, I have a doubt.
Yeah. Yeah.
So, ma'am, whatever the prediction that model predicted is only based on the texting data?
Yes, yes, the text data that I have given. That's why it has printed none for R squared, and also for mean squared error we have got zero because the data was not much, right? That's why. So when we
Yes,
will
ma'am.
be working with any of the CSV file, there the data will be like the data would be much, then the data would be then it will be predicting accordingly. Since I have only taken here, you can see only, right? I have only just for a simplicity purpose, just to make you understand how the code works and how we can do the steps accordingly. I have only taken five. Five data for the x, like five independent variable and five dependent variable. So with that, how the model will understand, right?
Yes, ma'am.
Yeah. So that is basically the case. Okay. So let me just give you a real time, like how actually it works. Let me just help you out to understand how the like the how the inner formula also works. Okay. So let me just give it to like that. Okay, so the first stage, we will be needing to collect the data. First is collection of data. So I am putting much of effort in the very first stage because for all of the other processes also, the stages would be same, but the equation would be different. But or the concept will be different, but the steps will be same. So if you understand one thing for linear regression, if you understand each and every step, for others also you'll be able to understand each and every step. You need not to put extra effort to understand each of the steps. There you just need to change the formula. Then how the things are working, in what perspective the things are working, you'll be able to understand. Okay. So we can just think of about temperature, and we can think of like, as we know, we tend to crave ice cream more in the seasons more because it's hot outside, so we tend to crave for ice cream. So we are taking the data like that. So based on the temperature, how much cups of ice cream is being sold, we are taking that into consideration here. So we are just taking that kind of data. Okay. So we are taking temperature. So we are taking into degree centigrade. Okay, just a minute. We are taking it to degree centigrade basically. Okay. And then we are just moving in to ice cream sold per cups actually. Okay. So here we will be getting, okay, just a minute. So here we are taking the temperature, suppose 20 degrees centigrade, then 22 degrees centigrade, then 24 degrees centigrade, 26 degrees centigrade, and 28 degrees centigrade. Okay. And against this is X, and for Y, so this would be the Y, that is our target. So for this, we are getting the values. Suppose 50 cups sold against 20 degrees centigrade. Then we have got for when it is 22, like 60 cups being sold. When it is 24, we are seeing like 65 cups has been sold. When it is 26, we are getting around, suppose 70 cups sold. When it is 28, we are getting around 80 cups sold. Okay. So X is the feature. So X, that is the feature, that is temperature. Next is Y, that is the target. That actually the ice cream sold. Right? So now we need to find the relationship. Like roughly, if we plot this up, like 20 against 50, 22 against 60, how the plot will be, we can take into a consideration. Okay. So each data point like this, how we have plotted it. So we will be getting another plot based on this data. Right. So basically, we will be getting, since this is absurd, we will be getting one as one outside, and rest one, two, three, four data will be getting in line. Right. So how now our first step, while we have studied, our first step is what we need to fit a line. Right. Fit a line basically. So what we need to do, we need to get into a formula. So what we are doing up here, we are using the formula as y equals to p0 plus p1 dot x. So here we will be putting each of this accordingly. So B0 is the intercept, and slope B1 is the slope. So based on this data, we can just predict, based on this data that we are having, then the line we will be getting, we can definitely predict what is the slope of the line and also what is the intercept of the line, right? So we can take into consideration and make it up around, like, we can, for an instance, based on that data, we can think it of B0 as suppose 10 for an example, and B1 we will be considering at as 2.5. Okay. Okay. So now when we will be putting it, the Y value against any of the X value, that what will be 10 plus 2.5 into any of the X value. Suppose we can take 30. Right. Then what y will be getting? That is getting around 10 plus 75. 75, that will be around 85. So will be sold around for suppose 30 degrees temperature. What would be the number of ice cream sold? That is 85. Okay. Okay. Understood how we are doing it, how the process has been made,
Yes,
like
ma'am.
how we are putting it into consideration.
Yes, ma'am.
Okay. Then only we will be plotting
Yes, ma'am.
for this, we will be plotting it.
Okay, ma'am.
And if we are getting the straight line passing through, we can definitely see that how the line is getting into fit and how we can take it into consideration. Okay. Clear, everyone?
Yes, ma'am.
Okay.
Okay, ma'am. Yes, ma'am.
Then we'll
Yes,
just,
ma'am.
yeah, great, great. So we'll just move into next one, that is logistic regression. So anyone having idea about logistic regression? What is logistic regression?
Ma'am,
Ma'am,
it
like
is
we use it for binary classification
Okay.
to classify between
Anyone
two
else?
categories.
Yes, yes, right. So in the previous section, we have seen about linear regression, where we are getting generally straight line, right? So because we are getting like continuous values we are getting, but in case of logistic regression, we are getting categorical values, or in certain cases, we can check it out as like the binary values. Suppose in a scenario where we are getting yes or no, then there we are getting this binary values like either 1 or 0, basically. Okay. So in that format, we are generally instigating and working with logistic regression. So in logistic regression, we can think of an example where we can go ahead and think like how we can take the features as study hours, right? How many hours a person study, and in return we can check if the person gets passed in the exam or failed. So study hours will be varied, like the X value will be varied, but the output, like the Y value, that is the dependent variable, will be either 0 or 1, right? So let me just show it up in an example format. So collecting data. There we are taking the example as pass or fail. Pass or fail data we are taking. So here what we are taking hours of study. Hours of study, that is X basically. So that can be, so I am just writing horizontally because writing it vertically, it is taking time consuming. So for hours of study, suppose a person is studying for 1 hour, then 2 hours, 3 hours, 4 hours, 5 hours, like this, 7 hours, the person has studied. Okay. So this is how the X is varying. Now, pass or fail. So pass or fail. So basically pass, we are putting it as 1, and fail, we are putting it as 0. Okay. So this is why that is dependent variable. We are getting 0 for 1 hour. If only 1 hour study, the person will get fail, of course. 0, 0. For fourth hour, we can think the person passed. For fifth hour also person passed, sixth hour also passed, seventh hour also passed. So this is how an example of logistic regression looks. So based on if this data is given to a model, right? So what inside the person, what inside the model will get? Can you tell me? Suppose this data I have given to the model. So what inner details or the inner pattern the model will understand or get?
More hours of
Ma'am, it's
study will increase
hours is
the
increasing.
chances of
Then
passing.
we will chances.
Yes, right, exactly. So it definitely what the details what we get into consideration here, that is less study hour,
We may
that
fail.
is fail, and more study hour is pass. Right. So we are taking into consideration like that. So here, why we are not using linear regression? That might be a question that comes to our mind. So we have seen in case of linear regression, what we have seen the straight line. So if we are getting only 1, 0 or 1 value, we will never get the straight line. We will never get the straight line. So if we try to fit it in a straight line, the predicted value will go either to 0 or 1. So which doesn't make a sensible probability that comes into that we can get into a straight line, right? So we will be getting either 0 or 1. So let me just insert it. So this is the line. This is x-axis. This the other one is this one is y-axis. So for 0, for any values in x, we are getting either 0 or 1. Okay. So here, suppose I am writing it as either 0 we will be getting or 1. But that is not more mandatory. Like that won't be like that is mandatory in this case, but we won't be getting a straight line curve, right? So in that case, we will be getting a sigmoid curve, that is a S-shaped curve. Here I'm not getting it. So this kind of graph we will be getting. This kind of graph, because here only zero value will be there, here only one value will be there. So and we're just using this S curve to like map the prediction, like 0 and 1. So here only 0 will be there or 1, like this straight line and straight line. And this we are just mapping off. Okay. So we need to see the sigmoid function for this. So let us just see the sigmoid function. So sigmoid function, how it will be working? So it is probability oriented. So it will be probability y equal to 1 given x. That would be equal to 1 by, we'll take 1 plus e to the power, that is small e to the power minus b0 plus b1x that is exactly the sigmoid function. So P y equal to 1 given x, that is probability that y value will be 1, that is the value the student will pass given the number of working hours, number of studying hours. Okay. So this is actually the sigmoid function. This is what we want to get in through. And B0, of course, it is the intercept. B1 is the coefficient, or we can say the slope value, basically slope we are getting. So in output from this, we will be always getting anything in between 0 and 1, right? So that's why we can get in through. So similarly in this form, we want to put in this, we need to fit the model in. So when p equals to 1, we will be putting, right? Suppose we need to fit the model. Fit the model. So there we will be getting the values accordingly. Then for P value, that is probability that we will be getting the Y value as 1. So how we will be checking? So we will be getting 1 by 1 plus E, sorry, E to the power. Suppose minus, and we are taking this value, that is b that is slope value, sorry, intercept value, that is b0 as intercept. We are taking it as -4, like as of now for consideration purpose I am taking. Else we have to do all of the operations up, we need to get the intercept from that, and then we can find it out. So just we are doing taking -4, and 1 is the slope into x we are doing, and we are writing it down. So suppose after doing it all, we are getting the value as whatever be the value, we are getting in between 0 to 1. So that actually fits here. Anything in between 0 to 1, this is the position where we are getting 1, and this is actually 0. So here we will be getting all accordingly, right? So this is how, in case suppose the person is studying uh, any of the person is studying for 3 hours. So how it will be? It will be definitely 3 minus 1, minus and minus plus. So it will get around 1 by 1 by 1 plus e to the power 1. E to the power 1. So how we are getting this e to the power 1, you understood, right? Guys?
Yes, ma'am.
So it is, we have just taken this person has studied for 3 hours. So -4 plus 3, 1 into 3 comes up to be 3. Let me just put it to this. So 1 cross 3, that is 3. So it is -1, minus and minus, it is giving plus. So e to the power 1, 1 plus e to the power 1 we are getting. So here the value 1 by 1 plus e to the power 1, that is we are getting 1 by 1 plus 2. That is we are getting the value as approximately 0.27. Right. So the probability is 27% that that they will be likely to 27% is the probability that likely the person will pass. Right. So this is actually it is when we will be putting it around 60%, like 27% probability that the person will pass. That means the majority section that the person will fail. So of course we will be considering the person will fail. Suppose if the person studies for 6 or 8 hours, then of course this value, this 0.22, that will come up more. Suppose for 6, if we are putting it as 6, this x value we are putting it to 6, we will be getting the value as we will be getting this probability value, or this that would be nearly around 80 plus or 88 around. 88 around we will be getting 88%. So we will be considering if a person study for 6 hours, there is a likely chances that the person will pass. Right? Clear? Understood?
Yes, ma'am.
Okay. So here we do keep a threshold. Here, basically, we do keep a threshold. Generally, we keep a threshold as 0.55. That is basically needed for classification. So, generally, if the probability value that we are getting that is greater or equal to 0.5, like here itself, we are getting. Suppose I have taken 88%, but actually, when we will be getting 0.88, right? So, this is actually 0.88 is actually greater than 0.5, right? So of course we will be considering this person will pass. So we generally keep a threshold. Just a minute. So this person will pass, right? So since this person will pass, we will be giving the count as 1, because we have taken the categorical value 0 or 1. If pass, we are taking 1, or if not, suppose the person studied for 3 hours, so we are getting 0.27. That is, of course, less than 0.5. That is the threshold value. So we will be taking the person will fail. So we will be considering 0 value up there. Okay. So this is how we are actually classifying. And next, when we will be visualizing, we will be getting either 0 value or 1 value. That is the sigmoid kind of curve we will be getting. Okay. Understood? Clear?
Yes, ma'am.
Guys,
Yes, ma'am.
Yes, ma'am.
Yes,
everyone.
ma'am.
Yes, ma'am.
Okay, fine. So let us just write a code for logistic regression. Okay. So first, you people tell me what we need to do in case of the first step of logistic regression. Tell.
Ma'am, first we need to import what are the
Import.
necessary libraries for that one.
Yes,
Then we
exactly.
need to data, and we need to give what are the data and a data frame.
Right, right, exactly, exactly. So we need to import libraries, right? So tell me what libraries I should take into consideration. So it has already came, and no option. Yes, so it has already came because we are here. We are generally using like that. Yeah, tell, please tell.
Pandas, scikit-learn, and we can
Yes,
import
exactly. Yes, exactly. So we need to take into consideration the data set. So the same data I will be taking into consideration. Study hours
and if
and
we want
pass
to like
fail. This one. Yeah. Tell.
If we want to like median mode and we have
Your voice is breaking. I am not getting you. Your voice is actually breaking. I am not getting you.
hello ma'am, now I am audible.
Yes, yes, audible. Tell.
Hello ma'am. Now
Yeah.
now my voice of
Yes, audible, audible. Tell.
if we want to like calculate mean, median, and mode, we will use NumPy for that for numerical calculation inside our data set. If we are working with a data set,
Okay, got it.
having so many numerical values like fraud detection and all.
I got it. Fine. So we will be taking this value. So we will be considering what we actually calculated. We will be taking that only. For 3, we have taken 0, we have taken 1, 1. So this is our data. So I have taken this similar data that I have given as example. So here also I have taken the same data into consideration. Now, after we have created the data, what is the next step?
We just
What is the next
convert to
step?
data frame.
Read to data. Exactly. Yes. We need to convert to data frame. So we need to convert pd dot data frame. Yes. So after that, what we need to do after we have created the data frame, we need to define the features and the targets, which is our independent variable and which is our dependent variable that we need to take into consideration. So here we have taken into consideration and put it into in the form that we will be getting that in the list format. Okay. So features and feature variable and target variable we have considered. Now the very next step
Ma'am,
is splitting the data. Yes, yes. Tell.
can't we take like 10 examples? You have taken 7.
Yes, I have given you this example, right? Yeah, and also given into
Because
count with that. So I just wanted to check how it works. So that I have taken this as an example. Okay. So
okay,
now
ma'am.
we will be splitting the data. So for splitting the data, we will be doing X train, X test, Y test. This all we will be doing. The same here as we have taken. And next we need to create a create and train a logistic regression. For that we will be doing model. We will be doing model equal to logistic regression. Then model into fit, we will be giving X train and Y train. X train this one and Y train this one. So this one we will be we will be putting because this is the stage where we need to make our model learn and make our model understand what are the details. Understood. So we are creating this logistic regression model up here, and we are training the model based on our X train data and Y train data. Okay. Now we need to predict how it is working and how eventually we will want to get in through. So for predicting, we are using Y predict, model dot predict, and it has to predict on the X train data. The X data we will be giving and the Y value we will be getting in output, right? So we have given this X case data into as an attribute here. Now we need to check the performance. So we will be checking the performance based on accuracy. So let me just get the accuracy. Uh, accuracy so equals to accuracy 4, that would be X test and Y test. Yes. Next, we need to, I don't want to report this classification. I don't want. So next, what we will be doing, I will be printing this. I will be printing the predictions. So why predict I want to print. Along with that, what I want to print, I want to print the accuracy. So I will be printing the accuracy. So accuracy is being printed up here. Next, if I want to print the slope and intercept, that also I can do. But as of now, I will not go ahead and do that. But I will just print the prediction, what is my Y predict value and what is the accuracy. So let me just run the code. Yes. So I am getting the prediction. The predicted value is 0 up here based on it has taken any of the value, random value from the X test. So for that, the prediction is 0 and the accuracy is we are getting as 1. Okay. Got it? Understood?
Yes.
Guys, how
Yeah,
we are
ma'am.
doing it?
Yes, ma'am.
Okay. Fine. So
Ma'am,
next,
accuracy.
we will,
Excuse
yeah,
me, ma'am.
yeah,
Accuracy one means it is predicting right.
yes.
I mean 100% accuracy.
Yes, yeah, 100% accuracy we are getting. Like the model, that is if the model accuracy is 1, that is model predict all of this phase data that has been taken into consideration. It has taken it correctly. So the accuracy is 1. Like the accuracy is 100%. Okay. So here we have taken 0, comma 0, right? So if we are getting 0, comma 1, then the first student prediction is to fail and the second student prediction is pass. So here 0, comma 0, that is first student prediction is fail and second student prediction is also fail. Okay, understood? Clear?
Okay,
Yes,
yeah,
ma'am.
ma'am. Got it, ma'am.
Okay, okay, got it. Yeah. So then we'll just move on to rigid regression. We'll just start with some like want to get into details, not much details. We'll see the code tomorrow session, but for today we'll just take into consideration about what rigid regression is, how we can think it of like that, and what exactly it is that we will be seeing through. Okay. So here we have taken into rigid regression. This much is done. Next is ridge regression. So basically what it is a very simple and easy to understand. Uh, like after anyone who has learned about linear regression, then gone ahead with logistic one, this would be easy for that person to get in through. So ridge regression actually is a type of linear regression that we are would be uh, regularizing. That is L2 basically. We also call it as L2 regularization. So what actually is the main goal? The main goal of ridge regression is basically to prevent overfitting. Okay, so we do get any cases where we get across about overfitting cases, right? So it actually prevents overfitting when our model becomes too complex or our model becomes too bulky or the data set that has been given that is not like that is making our model too complex or anything like that. In that very scenario, the main goal of ridge regression is to prevent overfitting. Okay. So when overfitting actually happens, yesterday we have discussed. Can anyone tell?
Ma'am,
We
when
will.
model accurately, is audible?
Yeah, please tell. No, no,
When the
no. Your
model
voice is
learns
really
too
low.
much from the data.
Yes, actually. So overfitting happens when the model fits into the training data very well. The training data that has been given to the model, in that very data, it performs very good. It performs very well. But when our predicted data is given to it, when it gets into any of the different data or new data, it cannot perform accurately. Okay, it fails actually in that session. So it fails to predict the new data accurately. In that form only, we considered this session and we call it as overfitting problem. Okay, so ridge regression adds a penalty to the size of the coefficient basically, so that the model becomes simpler and more generalized, so that it can be used easily. Okay, so in very simple words, we can think it of like the similar way as we have used multiple linear regression. The formula I have, I guess, written. Just a moment. Yes, this is the form of a multiple linear regression. So it is in the form of normal multiple linear regression. The ridge regression, what it does, it adds a penalty term. Okay, it adds a penalty term to the cost function. So anyone well aware of cost function? What is cost function?
Ma'am, it is
Okay,
actually the difference between the predicted value and the actual value of a model.
okay. The actually what we did, the sum squared
Ma'am,
error, what we did, this is sum y minus y predict, like the actual minus the predicted, the square of it we did, right? So this is SSE, that is sum squared error. That is actually the cost function. Okay, this is actually this cost function. So just a minute, let me just copy it down. In case of ridge regression, what we do, so we just add an extra term, a penalty term we are using. So here, this is the form. So what we are doing actually up here, we in the cost function, we are just adding our cost function, we are adding up SSE, that is that is sum of squared error, plus we are using alpha, basically consider it as alpha. Okay, and accordingly, like I don't want to put it and like from that notification up, like that from that section up, I just put it like that. This is basically given in alpha format, and then we are doing the sum from I value, sorry, I value from 1 to n. That is the summation operation we are basically doing up here, and we are putting b b I and is doing the square of it. Okay, so this is actually the penalty term. So BI actually the slope of the features, that is actually the slope of the feature, and alpha is the regularization strength. So how much penalty you want to give, that is alpha, that is the regularization strength, that is A. Okay, here I have represented it with A. So that is the regularization term. Okay. So what is the reason why basically we use this regression? It actually reduces the overfitting because certain multiple linear regression or linear regression, basically multiple linear regression where the number of independent variables are more. So we make our model too complex. And if there are many noisy data or there are many outliers, right? So in that case, we can use this ridge regression, and we need to handle the multi-collinearity also, right? So in this case, ridge regression play a very important role. So it helps to handle the multi-collinearity when the features are highly correlated. So it does handle that, and it also keeps the coefficients small, which improves the prediction between the new data, prediction on the data very well, so that it predicts the data very well. Understood?
Yes, ma'am.
yes, ma'am.
Yes, ma'am.
Okay, okay, got it. So in tomorrow's session, what we will be doing, we will be going ahead and we have done with logistic. We will be seeing how we are doing this ridge regression. Okay. And we'll be going ahead with lasso regression, that is L1 regularization. This one is L2 regularization, and lasso is basically L1 regularization, that we will be learning how we will be doing this one, and this elastic net regression. This one we will be also taking into consideration and see how it is making the necessary changes, how taking into consideration our model learns better. Okay, guys, understood?
Yes, ma'am.
Yeah, ma'am.
Yes,
Yes, ma'am.
ma'am.
Okay,
Yes,
great.
ma'am.
So we'll just stop our session today here. We'll just wrap up our session here. As of now, anyone having any doubt?
Yeah, excuse me, ma'am.
Yeah, tell.
Ma'am, I'm very new in this batch. Ma'am, I'm Kajal, and ma'am,
Okay.
I did anything like what is going happening. Uh, like where from I get projects and where have to I submit and what project I should make. So can you please tell me?
Okay. So what has been taught in today's session? You understood that?
Yeah, ma'am. Yeah,
Okay, you understood that, right? Okay, fine.
yeah,
So the thing is, as you are very new, I understood. Yesterday only, in yesterday's session, you were there, or today is your first session?
ma'am. Today is my actually I'm there, but due to network issue, uh, I couldn't join again. So this
Okay.
is my first
So
session
basically,
that I
today is your first session technically that you are attending, like from first to end, right?
yeah, yes, ma'am.
Okay, got it, fine. So see, the thing is, you have been added in one group, right? There, all the details are mentioned, where the link of joining and the details are mentioned up, right?
Yeah, yeah, ma'am.
Okay. So there itself, you will be getting the project details, the week one project and week two project you will be getting. There is
Yeah,
a PDF file
exactly.
is actually been that you got.
Yeah, ma'am. Exactly what I'm not getting clearly, like what is project assigned and from where I will have to start.
Okay. So I guess the recordings, the YouTube link has been given to you. You can check the recordings. From there itself, you can follow the class accordingly. From there itself, you will be getting the sessions up. Okay, for AI ML, my name is Abhipsha. So there, I guess the name AG has been mentioned. My name is Abhipsha Guha. So the name is
Yes.
AG has been mentioned. Along with that, AI ML class one, class two. I guess in that format they have uploaded. So you can check it up from there only. Okay. So for first five classes is for first week session. After on Friday, they have been given with allocated with the project. They have worked on the project and submitted on Monday. Similarly, for the week two, the same thing is happening. Okay.
What is first week project like? I'm not doing any project right
See,
now.
if you're not getting, you can directly mail them. Since you have joined later, you might not get the PDF, like you might not get the access of the PDF. You just mail to the HR. They will definitely revert you back, or give you the project details, like the project PDF for week one and week two. There are many projects are there. You can choose accordingly. And week two, I guess they have been given with the EDA project. Okay, so data set you need to choose it from the source has been mentioned there, maybe Kaggle or any of the other webs. From there you need to get the data set, and you need to perform the EDA analysis, and you need to make interactive plots. Okay, that is week
Okay.
two. And guys, can anyone let me know what is the first week project? I cannot recall at this moment. If
Ma'am,
you
in the
remember,
PDF,
can you
it's like in the PDF, it's given like the basic data analysis we have to perform on the data set.
Okay, that is fair enough. So, Fida, you are there. So, what you did in the first week, can you just let me know? Because you have presented first. I can recall. Fida, you are there. Okay, maybe she is not there, but you can definitely take into count with the PDF file that has been given. So from there itself, all of the details has been mentioned out there. You can check from there and eventually can work accordingly. Okay, Kajal?
Okay. Now I have one more doubt. Like where I'm submitting
Yeah.
in your mail ID or someone else?
No, there I guess a mini project mail ID has been given. There you have to submit the project, and also since you haven't presented, so you have to record your presentation in Zoom. You have to open your Zoom, like the Zoom application. There you have to switch on your camera and microphone, and there you need to just present your project, and eventually you have to just make the presentation like how your project is being built, like that you have to make the presentation, and eventually you have to present it like that, and you have to download the video. Actually, that is like, if you have that Zoom file application, actually Zoom application installed in your laptop, it gets easily downloaded from that. You need to upload that downloaded file, upload that video presentation file in your Google Drive, and give us the access that if anyone having the link, they can view it like that, and and paste the link in the mail ID, giving that is like giving the title as video presentation for week one submission, along with attach the project, and that in this way you can submit. Okay.
Okay, ma'am, I got it.
Okay, okay, fine. So in this way, you have to submit week one, week two project, and this Friday you'll be given the week third project also. Fine. After we are done with all of this, you'll be given week third project also. Okay.
Okay. Ma'am,
Okay.
like how
Yeah.
much time? How much time for these two projects which I am not done?
So see, as of now, you take your time. At least in the upcoming week, you have to submit. Try to submit by upcoming week.
Okay. Okay, ma'am, I will
Okay.
try.
Okay.
Yeah.
Okay. Fine. Okay. And in between, you face any issue, you can let me know. I'll try to help you.
Okay. Okay. Thank you.
Sorry, I didn't get you. Can you come again?
I just say thank you for support.
Okay, okay, fine. Okay, fine. Not an issue. I thought something else. Not an issue. Okay, fine. Then I guess no one have any doubt as of now related to anything, right? Guys,
No, ma'am.
No, ma'am.
No, ma'am.
okay, okay. Okay, fine.
No,
Fida,
nothing
I
clear.
was just calling you. Just a minute. Fida, I was just calling you. Can you just remember on the first week what project you did?
Unemployment rate analysis I had done. Ma'am.
Okay, so there, what was there in the PDF? Basic analysis, right? Based on the like kind of ED analysis like that itself, and
Yeah,
hypothesis
EDA
testing, right?
and hypothesis testing. Yep.
Okay, 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 Kanjal, you can follow that as well. In the first, for the first week project, you can do you can take the data set and do the EDA along with the hypothesis testing. Fine?
Okay, ma'am.
Yeah. Priyansh, you are saying something?
No, ma'am.
Okay, fine. Okay, got it, fine. Okay, then we just wrap up our session today here. Okay?
Okay, ma'am.
Okay, ma'am.
Yeah. Okay, bye guys. Bye bye.
Bye.
Thank
Bye.
you.
Bye, ma'am.
Bye,
Thank
Bye,
you.
ma'am.
ma'am.
Thank you, ma'am.
Bye. Bye,
Bye.
ma'am.
Bye bye. Bye bye.
Bye, bye. Take care.
Yeah, bye.